is a deadlock situation. And now the P2 is demanding, as I told you before, 15, 5, 7, and the system have available 5, 3, 4. So it means the P2 is also in the deadlock situation. So P2 is in a deadlock situation because the PI finish is equal to false for the P2. And let's know about the P3. P3 demand how much? 7, 8, 9. 7, 8, 9. The system have how much? 5, 3, 4. So you know that. Now what's going on? Now this condition become true. Work is less or equal to what? Need. Work is what? Work is this available resource. Need is what? Need is this. Where the need is greater than or, yeah, here the need is greater than what? The need is greater than available resources. You can also say that work is less than the needed amount of resources. So based on this condition become true, the finish I will be false. When the finish I is false, so we can say that the system is in a deadlock situation. Now the last process is P3. So dear students, we detect that the system is in a deadlock situation. Idris, now is it clear? Ahmad Shakur?
Yes, sir. Now I got it.
Very good. So we can say, dear students, that the system is in a which state? The system is in a deadlock situation. Why? Because our three processes, P0, P2, P3, their finish I is equal to false. It means that the need resources are greater than work. And now the system should think about the recovery because the deadlock is already confirmed. And now the system will take decision to recover the system from this deadlock situation. Okay, guys, let's try to understand that what decision will be made by the system to recover the system from this deadlock situation. Don't forget that we confirm and we detect the deadlock in this example. And we found that three processes are in a deadlock situation. Okay, let me save this for you guys. Okay, there's another example. You guys can also work this example, okay? That was the previous example because I used that you guys was already clear or in that example, okay? Once the deadlock is confirmed, then the system will initiate what? Okay, no, this is the same. Yeah, when the deadlock is confirmed, then the system will try to recover or recover these processes from the deadlock situation, okay? And for this process, the system will take multiple decisions. Dear students, it's up to you that what should you do? What should you design in your recovery scheme, okay? We are going to study some common things which you can define in the recovery scheme. The first thing, in order to recover the system will abort all deadlock processes. The system will abort what? All deadlock processes. Like how? You can see, dear students, in our system, these three processes in a deadlock situation. So the system will come, they will kill the P0, they will kill the P2, and they will kill the P3. Because when the system do you remember I told you that when a process is, let's suppose Pi is holding a resource, let's suppose R1, that is holding this resource, okay? This is the request state, sorry. When the Pi is holding R1, but Pi is also waiting for R2, Pi is also waiting for R3, you know, the Pi is in a deadlock situation. And this is called hold and wait situation. Do you remember I told you that we should tell to the Pi, you should release this R1. Why? Because the system will say, I cannot allocate this R2 and R3 to you. So then why you are waiting? So you have to release this R1. Releasing R1 means that the system will abort this PI. They will kill the PI. Because they will tell him to let him to execute next time when I will have sufficient resources. Then I will able to satisfy the request. So same like that. Here, the system will try to kill the P0, P2, and P3. And they will, why? Because they will let these three processes to execute next time when the system will have more resources. But maybe you guys are thinking that how the system will got more resources. Maybe some processes will be released. When the deadlock is divided, of course, this other processes which are demanding less resources, they will be satisfied, they will release their allocated resources, then the system will have rich resources and they will satisfy the request. Or if not, then the process cannot execute. Or not, then the process cannot execute. Like you know that you cannot run a game in your PC when they cannot satisfy the required amount of resources, then you cannot run even. So then the process will be not able to execute. When the total resource of the system is less than the need amount of, or the maximum claim of a process, okay? Okay guys, so one thing is clear, that the system will abort all processes. Which processes? Which are in the deadlock situation. This is one approach. The second approach, abort one process at a time. Okay, abort one by one. First abort P0, then see, can the deadlock situation will be removed or not. Then come that abort the P, what was that? I think P2, abort the P2. And then if not, then abort the P3. So one approach is abort all the processes at a time. Second approach is that abort one process at a time, not abort all processes at a time. Okay, for these two cases, or for these two approaches, aborting all or aborting one by one, which order should we choose? The following order should we choose. It means that, let's suppose, if Idris say that we should select the second one, abort one by one. But you know, here I have three processes. Which one should be the first to abort? Is the system should pick this P2 for first abortion, or this P3 for first abortion? Which one should be selected? So for this purpose, we will follow the following order. The following order is, say, priority of the process. So check the priority of a process. Find the low priority process in this list and abort that. The first order is saying this. Second, how long the process has computed and how much longer to completion. See the process waiting time and see the process next CPU burst time. If it is too much high, let's suppose if a process is waiting for a long time, so don't abort that. If a process is waiting for a short time, abort that. Or let's suppose if a process is required more CPU time, don't abort that, because the process already completed for a long time, so don't abort that, because they will need some less time of the CPU to complete themselves. Or maybe see that if a process needs more CPU time, then abort that. I'm sure it's a little bit confusable, but don't worry, I'm repeating it. See, dear students, for example, I have P1 and I have P2. P2 is, their burst time is 5. For example, the burst time is 5. P2 burst time is 10. P2 burst time is 10. Where the P1 is just only complete their 1 burst time, and the P2 is complete their 9 burst time. So 1 and, yeah, let's take it 8 because the line is here. So which one should be terminated? This one should be terminated. Why? Because they take their very less CPU time. and this P2 is already processed more than 70%. So why should we abort this? Let's first abort the others like processes like P1, and may the cycle will be, the deadlock cycle will be removed. This was the one case in this case number 2. The second, how much longer to completion? We can see, dear students, that here the P1 required more CPU burst time, and after that they will be complete. So kill this one. The P2 will require more time, very less more time for a CPU to complete this. So don't abort this because they already process for a long time. Okay, guys? So it means that if a process consume less CPU time, okay, and they will require more CPU time, so kill them. If a process consume more CPU time and they will require more CPU time, don't abort or don't kill them, okay? 3, resource the process has used. Check to the resources, how much resources are used by the process. Like for example, how much resources are allocated to the process. Let's suppose, for example, P1 and P2. To P1, 10 instances are assigned from the resource A, and 15 of the resource B, and 10 of the resource C. So see, these are very much resources. And here for P2, 2, 3, and 5. So this third option say that kill this one, because once we kill them, they will release a lot of resources, and these resources will be plus with the work, and the system will have more free resources. So kill this one. Don't kill this one. If we kill this, so they will release very less resources. So kill this first and check the deadlock is divided or not. If not, then kill P2 too. So number 4, resources processes needs to complete. How much more resources need by a process to be completed? Check also that. Like for example, here in our example, the P3 required more resources. The very heavy process is P2. P2 required this much resources. So if we kill this, so may the system will decrease some, we will decrease some burden on the system, because this is a very heavy process and they require very much resources. So let's kill them and check that now the system can satisfy the other processes resources or not. So kill such type of processes first according to the option number 5, okay? Come back to the slide. According to the option number 5, how many processes will need to be terminated? How many? Define the number of processes. Number 6, is process interactive or batch? You can also check the process type. Is it interactive process or is it batch process? You know what are the interactive, what are the batch process? So you know interactive process have more priority, batch process have less priority. So if 2 processes, let's suppose P1 is interactive and P2 is batch, then kill P2 first and check the system situation, okay? Okay guys, so this was the last option. Okay, so here the resource preemption. Selecting a victim, minimize cost. Selecting victim means victim, a process which should be killed, okay? That will be a victim. So we have to minimize the cost. Minimize of cost means we should follow all this order. We should follow all this order when we are going to kill a particular process. Remember, when you follow this, then you will kill a process which will be not costly for you. That means that which will not have a bad consequences, okay? Yeah, the next is rollback. Return to some safe state, restart process for that state. We have to restart the processes, all the processes. Because what? We have to come back to the safe state. You know, sometimes the system will automatically kill your all open application and your system will take a new breath, like a fresh breath, okay? You will say that why my application is closed. Actually, your system was in a deadlock situation and your system killed your all processes. Okay, and now they are telling you that open your applications one by one again. Starvation, some may process. Okay, so there is a problem that if you follow the previous order and based on that your system is picking a particular victim every single time, then there is a problem that that process will become the victim for each and every time. So they cannot show that once a process has become victim, they will not become victim for the next time. Because when your process is qualifying all these conditions, so they will become victim and they will be every single time aborted by the process during the deadlock situation. The system cannot guarantee that once victim should be not the victim for next time.